2024 A-Level Combined Mathematics Paper 2 Part B, question number 17, Part B. Part A of this same question was discussed in a previous video, link in the top right. Part B of this question has to do with statistics and frequency distribution. The question says, the times taken to solve a puzzle by 20 students were coded by subtracting 10 from each of the times and then dividing the whole thing by 2. The question then says, the frequency distribution of the coded data with two missing frequencies is given below. So we can see we have some class intervals, and we can see in the 0 to 2 range we have two frequencies. In the 2 to 4 range we have F1 which is missing. In the 4 to 6 range we have 9. In the 6 to 8 range we have missing value of F2, and in the final range of 8 to 10 we have one value. Now considering this, they say the estimated mean for the coded times is given to be 4.4 minutes. And given this information, we are to show that F1 is equal to 6 and F2 is equal to 2. Now after this, they say estimate the standard deviation and the mode of the coded times, and finally they say now estimate the mean, the standard deviation and the mode of the actual times taken to solve the puzzle. Now until this point we were dealing with coded times. After this point, they say take all of the coded data you have and reconvert it back into the original values using the inverse of the coding algorithm that we have here, and then find the actual mean, actual standard deviation and actual mode of the original data set. Now to start with the question, let's go down and start filling in this table. So in this table, we have the class range and frequency that are already known. What we don't know is the mid value, the value of fx and the value of fx squared for each of these values, and also the total of fx and total of fx squared. So if we start filling them in, the mid value for 0 to 2 is 1, mid value to 2 to 4 is 3, and then we have 5, 7 and 9. Now considering that, if we fill in fx, we have 1 times 2 which is 2, we have 3 times f1 so 3f1, we have 5 times 9 or 45, we have 7 times f2 or just 7f2, and finally we have 9 times 1 which is 9. Now adding all of these together, we can see the sum of fx is equal to 2 plus 45 plus 9 plus 3f1 plus 7f2. So 2 plus 45 is equal to 47, and 47 plus 9 is equal to 56. So therefore we have 56 plus 3f1 plus 7f2 as the sum of fx. Now considering fx squared, we can fill in this value, and this value, but for right now I'm going to leave this value and this value blank. So considering the other values, we can see 1 times 2 is going to be equal to 2. So we have 2 here. Considering next value, 5 times 45 is equal to 225, so we have 225 over here. And finally, we have 9 times 9 here, which is going to be equal to 81. Now I'm going to leave these two blank for now, and we'll fill them in later after we find F1 and F2. So considering this setup, we can see, first off, the total number of students is equal to 20. Now according to that, the total of the frequencies line here must be equal to 20. So using that, we can say, since the total number of students, which is sigma f, is equal to 20, the sum of all the frequencies, which is 2 plus f1 plus 9 plus f2 plus 1, must be equal to 20. And therefore 2 plus 9 which is 11 plus 1 which is 12 plus f1 plus f2 must be equal to 20. So going down, we can say 12 plus f1 plus f2 equals 20. Now simplifying this down, we can see we get f1 plus f2 equals 8, and this is going to be our first equation. Now to make another equation, what we need to do is to consider the fact that the estimated mean for the coded times is given to be 4.4. Now the estimated mean, or just the mean, is equal to sigma f times x divided by sigma f. Now in this case, sigma fx is known because it's the value that we calculated right here. This is sigma fx. Now considering sigma f is just the sum of the frequencies, which as we know is equal to 20, since the total number of students that we have here is equal to 20. Now according to that, we substitute, we can see the mean is equal to 4.4, and on the other side we have 4.4 equals 56 plus 3f1 plus 7f2 divided by sigma f, which is 20. And rearranging this, we can see we get on the left hand side 88, and on the right hand side we get 56 plus 3f1 plus 7f2. Now if we take this 56 to the other side, we can see we can rearrange this to 3f1 plus 7f2 equals 88 minus 56, which is going to be equal to 32. So we get equals 32, and this is going to be equation number 2. Now using equation number 2 and equation number 1, we can find the value of f1 and f2. For this, what I'm going to do is to take equation number 2 and rearrange it by taking 3f2 out of the 7f2 and writing this as 3 times f1 plus f2 plus 4f2 equals 32. Now the reason I did that is because f1 plus f2 from equation number 1 is known to be 8. So substituting that in, we can see from equation number 1, we get 3 times 8 plus 4f2 equals 32. And rearranging, we can see 4f2 is equal to 32 minus 3 times 8, which is 24, which is going to be equal to 8. 32 minus 24 equals 8. And dividing both sides by 4, we can see we get the value of f2 being equal to 2. Now for f1, what we can do is to go back to equation number 1, substitute in f2 equals 2 and get f1. So doing so, we can see from equation number 1, we get f1 plus 2 equals 8, and therefore we get f1 equals 6. And with that, we have found the values of f1 and f2. So we can say therefore f1 equals 6, comma, f2 equals 2, and with that, we are done with the very first part of the question. Now after that, the question then says, estimate the standard deviation and the mode of the coded times. Now, if we start with the standard deviation, we can say standard deviation squared or variance is equal to sigma fx squared divided by sigma f minus sigma fx squared divided by sigma f minus the value of mu squared or mean squared. Now from this, we can see the value of sigma is equal to the square root of whatever sigma fx squared is divided by sigma f, which is 20, minus mu squared, which is the mean, is given as 4.4. So therefore we have minus 4.4 squared. Now going up, let's go back to the table and try to find the value of sigma fx squared. So going up, we can use the value of f1 equals 6 and f2 equals 2. So in the table, we have 3f1 here and 3 here, and multiplying them, we can see this value is going to be equal to 9f1. And since f1 is equal to 6, we can see the value here is 9 times 6, which is 54. Now for this value here, we can see f2 is equal to 2, and therefore we have 2 times 7, which is 14, times 7 again, which is 49 times 2, which is going to be equal to 98. Now, if we add all these together, we can see we have 2 plus 4, which is 6, plus 5, which is 11, plus 8, which is 19, plus another one, which is 20. So we have 20, carry the 2, we have 2 plus 5, which is 7, plus another 2, which is going to be equal to 9, plus another 9, which is equal to 18, plus 8, which is equal to 26. So we have 26. So carrying the 2 here, we can see we have 2 in the hundreds place, plus another 2 in the hundreds place, which is equal to 400. And therefore, sigma fx squared is equal to 460. Now from this, we can see going down, we have 460 divided by 20 minus 4.4 as being the value of sigma, or rather sigma squared. And if we take the square root of that, we will get the value of sigma. Now taking the square root here, we can see we have the square root of 460 divided by 2, which is going to be 23 minus 4.4 squared, which is going to be equal to 4.4 times 4, which is going to be 17.6, plus another 1.76, which is equal to 19.36. So we have minus 19.36. And subtracting these two, we can see 23 minus 19.36 is going to be equal to 3.64. So sigma is equal to the square root of 3.64. We can write sigma equals square root of 3.64, and the square root of 3.64 is about it's about 1.91. So therefore, we can say sigma approximately equals 1.91. And with that, we have found the approximate standard deviation of our set. Now after that, the question also says find the mode of the coded times. Now to find the mode of the coded times, we need to use the standard model equation for frequency distributions. That equation states the mode is equal to L plus delta 1 divided by delta 1 plus delta 2 times C, where L is equal to the lower bound of the model class, delta 1 is equal to the frequency difference of the model class in the class before it, delta 2 is equal to the frequency difference of the model class in the class after it, and C is equal to the class interval. Now going up, if we take a look at our classes, the class with the highest frequency, i.e. the model class, is this class right here. It is the class with the interval from 4 to 6. This class has a frequency of 9, where all the other classes have lower frequencies. So therefore, this class range is the model class. Now considering that, since L is the lower bound of the model class, we can see L is equal to 4. So going down, we can substitute into here mod equals, and instead of L, we can put 4. And we can also say the class with range of 4 to 6 is the model class. Model class. Now going back up, we need to find delta 1, delta 2 and C. So if we consider delta 1 and delta 2, delta 1 is the difference of frequency between the class and the class before it, which if we consider model class as 9, class before it is f1, which is equal to 6. So therefore we have 9 minus 6 for delta 1. Now similarly, delta 2 is equal to the frequency difference of the model class and the class after it. Now the class after it has frequency of f2, which is equal to 2, and therefore we have 9 minus 2, which is 7. So therefore, delta 1 is equal to 3 and delta 2 is equal to 7. So going down, instead of delta 1, we can substitute 3, and instead of delta 2, we can substitute 7. So we have 3 plus 7 times C. And if you consider the classes, each class is exactly 2 per units long, and therefore the class interval here is equal to 2. So doing that, we can go down and write C is equal to 2. So multiplying that by 2, we get this expression for the mode. Now simplifying down, we can see we have 4 plus 6 divided by 10, which is 0.6, which is equal to 4.6. And therefore the mode of our classes is equal to 4.6. Now after the question then says, now estimate the mean, standard deviation and the mode of the actual times taken to solve the puzzle. Now for this, what we need to do is to write down the coding and reverse it. So for this, let's say let x represent the original data, or we say original times, and y represent the coded times. Now according to this, what the question said is that the timing is coded by subtracting 10 from each of the times and then dividing by 2. So therefore, the coded value of y is equal to the actual value minus 10 divided by 2. And rearranging this, we can see we get 2y equals x minus 10, and therefore x equals 2y plus 10. Now according to this, this is the way that we can undo our coding. We have to take the original values being equal to 2 times the coded value plus 10. Now it's important to note here that in this kind of coding, some of the values get translated by the entire transformation, but some of the values get translated only by the multiple in front of the y. Now in this case, the mean and the mode are both going to be translated by the whole thing. However, the standard deviation, since it doesn't really matter where the midpoint is, the standard deviation will only be transferred by the 2. And therefore, if we consider the mean, mode, and the standard deviation of the used or the final data, which are going to represent with mu x, sigma x, and also capital Mx for the mode, we can say if mu x, sigma x, and capital Mx are the original mean, standard deviation, and mode respectively, then mu x is equal to the old mu, which is mu y, times 2, so 2 mu y plus 10, which is equal to 2 times 4.4 plus 10, which is equal to 8.8 plus 10, or 18.8. So the new mean, or the mean of the original data, is equal to 18.8. Now similarly, if we consider sigma x is going to be equal to 2 times sigma y. Importantly, it's not equal to 2 times sigma y plus 10. It's just equal to 2 times sigma y. And considering that, we're going to have 2 times the value of sigma y, which is about 1.91. So multiplying, we can see we have 2 times 1.91, which is equal to 3.82. So that's the value of the original set's standard deviation. And finally, if you consider the mode here, mx is equal to 2 times my plus 10, which is equal to 2 times 4.6 plus 10, which is going to be equal to 9.2 plus 10, or 19.2. And therefore, the original mode of the original data is equal to 9.2, or rather 19.2. And with that, we are done this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you fill in the table, filling in this bit right here gets you 5 marks, and filling this bit later gets you another 10 marks. So getting 460 here gets you 10 marks, and getting 56 plus 3f1 plus 7f2 here gets you 5 marks. Now after that, when you take the fact that the total number of students is equal to 20 and write 12 plus f1 plus f2 equals 20 to get f1 plus f2 equals 8, you get 5 marks for that. And similarly, when you say that the mean is equal to sigma fx divided by sigma f and substitute to get this equation right here, you get 5 marks for that. And simplifying that down, when you get 3f1 plus 7f2 equals 32, you get another 5 marks. Now using equation number 1 and equation number 2, when you go down, substitute, simplify, and find that f1 is equal to 6 and f2 is equal to 2, for getting both correct, you get 5 marks. After that, when you then find sigma squared equal to sigma fx squared divided by sigma f minus mu squared like this, and substituting the values like so, for substituting correctly, you get 5 marks. And then when you simplify, if you get square root of 3.64, you get 5 marks, but you don't necessarily get marks for the final answer here. You don't actually have to find the exact value, you can just find a square root of 3.64. Now after that, when you then try to find the mode and you substitute into the formula here like so, for substituting the correct values like this, you get 5 marks. And then after that, when you go down and find the final answer of 4.6, you get another 5 marks. Now after that, when you decode the whole thing, for writing the original coding and finding the decoding equation like so, x equals 2y plus 10, you get 5 marks. And after that, when you find the decoded values of mu x, sigma x, and mx, for each of them, finding 18.8, 3.82, and 19.2 separately gets you 5 marks each. And specifically, when you say that sigma x is equal to 2 times sigma y and not 2 times sigma y plus 10, you get another 5 marks for getting that. So that is the end of this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.